Hi guys, let's get started today's class. First of all, I would like to, show you the answer of the assignment of the last week. Here is the practice. So this is the reaction. This reaction is endothermic reaction, but proceed spontaneously. So please estimate delta Z and check the spontaneity of the reaction by the use of this delta S. So you can calculate very easily by the use of this equation, delta Z equal delta H minus T delta S. You have all the value of the delta H and delta S and T here. So it's very easy to calculate the delta H and delta S and delta G. Actually, this reaction have positive delta H. That means the endothermic reaction. And delta S equal 594 joule per Kelvin. Be careful, this is just joule. No? On the other hand, delta H should be kilojoule. So you have to change the unit from joule to kilojoule here. Okay? And you can calculate T delta S by the use of the 25 degrees C. Of course, this is the degree C. You need to change to the this absolute temperature. Then we can calculate the 177 kilojoule as T delta S. So by the use of this value, delta Z equal minus 11 kilojoule. This is negative. That means the reaction can proceed spontaneously. This is the answer, okay? And today, before talk of the today, I would like to how to check the disorder of this reaction, okay? Here is the important point of checking the disorder of this reaction. From 3 molecules to 13 molecules, from solid to liquid and gas, you can check the chemical equation here. The substrate is ammonium chloride and BaOH2. So 3 molecules before the reaction. On the other hand, we obtain 13 molecules here. That means the disorder in a system changed to the large disordered state. Okay, that means the delta S should be positive. Okay, and in other point, these 2 molecules are solid. On the other hand, this is gas, this is solid, and this is liquid. So maybe you can imagine that liquid and gas is much more freely than solid one. So disorder of the system changed to small to large. That is important point to think the delta S. So both of them shows the delta S should be positive. Then this reaction can proceed by the entropy, not enthalpy, okay, to proceed this reaction, okay? And we need to think about these 2 points to think about the delta S. And finally, we have this matrix to think the spontaneity of the reaction. If delta H is negative, there are two possibilities. Delta S is positive or delta S is negative. If delta S is positive and delta H is negative, you can see this equation. At all temperature, the reaction should be spontaneous. On the other hand, if delta S is negative, here is a negative one, in that case, the spontaneous at low temperature. Okay. On the other hand, this is, endothermic reaction. In that case, if delta S is positive, the spontaneous at high temperature, and delta S is negative, non-spontaneous at all temperature. So always you need to think about this matrix to judge the reaction proceed or not proceed. Okay. If you feel some confusing about this matrix, you can think about the ice melt. Okay. So ice does not melt at minus 10 degrees C. That means the low temperature. It's non-spontaneous, okay? So, and at high temperature, it's spontaneous ice melt. That means this one. So ice melt is this pattern, delta H should be positive, delta S should be positive. That is ice melt, okay? On the other hand, water freeze is a, opposite reaction. Of course, you can imagine the ice is solid and water is liquid. So from solid to liquid, in that case, the delta S should be positive. And as you may know, the ice have a large number of hydrogen bonds. That means the delta H, should be positive because, from the ice to liquid, in that case, the many number of hydrogen bond was, cleaved, and then the delta H should be positive, okay? And this is the assignment. Today is the last day of this class, so very short video, but this is very important and easy access to your class credit. And if you submit this assignment, maybe you can get the credit of this class. So this is very important. The assignment is here. The reaction shown below favors lower temperature to produce ammonia. Explain using delta H and delta S. Okay, and this is the important reaction known as the Haber-Bosch reaction. Okay, Haber and Bosch find this reaction and get the Nobel Prize. Okay, and in the case of this reaction, nitrogen and hydrogen to produce ammonia. The delta G of this reaction is, of course, negative, minus 33 kilojoule per mole. And I would like to provide bond energies of these molecules. NN triple bond is 945 kilojoule per mole here. And hydrogen have 436 kilojoule per mole here. And NH single bond have 391 kilojoule per mole here. So you can calculate the energy of, delta H of this reaction very easily by the use of these bond energies. So you can calculate here. And you can think about delta S very easily by the use of the number of molecules before and after reactions and state of the molecules. In this case, all molecules should be gas state. Okay? Then you can say delta S is positive or negative. By the use of these, speculation, you can explain the reaction favors lower temperature by the use of the matrix as I described here. Okay, so please write down this kind of explanation in the paper. Okay, so this is the last assignment, and thank you for joining this class, and I hope you enjoyed this class. And I hope that some of you joining the chemistry department in this university and do some graduation thesis or something. So see you then. Bye.